Hello interwebs, welcome to Let's Fix Computers. I've got a Lenovo here. This is an IdeaPad 5 14-inch. And this is no power, this laptop. It actually only came in today, but I thought I'm going to quickly have a look at this and just see if I can get a quick fix because it's Tuesday and I don't have a video for this week. So this one came in, the customer said it wouldn't charge, and there was no charge light. There's no charge light when you plug in a charger. They thought their charger was dead, and they said they'd put a multimeter on their charger and not had any output from it. I plugged it into my Lenovo charger, also got no light on the charger. So what I think might be going on here is I think that there's a short circuit in the laptop. When you plug in a charger, the charger's overcurrent protection is kicking in. So in any case, let's get the back cover off of this and see if we can figure out what happened to it. So roll the intro. I'm going to take these screws out the bottom and we'll do an inspection. So I want to look real close and see if I can spot any skid marks or anything. Might be on the bottom. Might be under there. Let's just lift that hinge and see if there's anything to spot. Otherwise, I might have to keep disassembling and get the motherboard out in order to spot anything. We'll do some quick measurements in a moment, just so I can ascertain what I'm getting into. Well, I can't see anything visible from here. Let's do some quick stabbing. So let's come under the microscope and take some measurements here. We'll start from the DC in jack down here, and we'll follow its wire along here. This guy flapping around, that's just the display connector that I've unplugged just to give myself more viewing space. And here's where the DC in jack plug goes into the motherboard. So we've got our red wires coming in. So we've got positive and a negative. So I'm going to put my black probe on a ground connection. I'm just going to use this screw hole to the left here. And let's check the resistance at the DC in jack. So we'll just probe that guy. And we're getting 119 kilo ohms. So that's completely normal. That's about what we expect. So the power comes in. It's going through this fuse here, then it's going up through this inductor, and it gets to the DC in MOSFETs. So we go through one, through another, and we become the power rail for the laptop. So what's that power rail looking like? It's looking like about 300,000 ohms, 300 kilo ohms. So that seems to be okay. All right. So I'm going to do some stabbing around in other locations on the laptop, see if I can find anything. I'm going to move over to, here's the CPU heatsink. I'll move down here. Under this section of the heatsink, we've got the CPU V-core MOSFETs, or power stages, or whatever they've put under here. And we've got a row of big capacitors here. So these capacitors, these should be on the main power rail, feeding into CPU V-core. So I'll just check one of these. Let's just jump onto the positive pin there. There we go. Those are very low, just under an ohm. So that is a short circuit. Whoops, I just fell off of my ground connection there. Yeah, so that's about half an ohm. Cool. Okay, we're getting somewhere. So if that is our main power rail, that's what I expected to find at these DC in MOSFETs. So we might have a slightly different power architecture here, where after these DC in MOSFETs, we're going into another power regulator somewhere else. And this type of architecture is called narrow VDC. It's caught me out before on Dell laptops, where you think you found the DC in MOSFETs in your main power rail, but actually you found just an input section. So I think what we're going to have to do is get this motherboard out so we can see where we go after here. you can see that we're going down through the motherboard through these vias, but we can't see where we're going from there. There's a few other traces going off here to just other stuff, but that's not our main power rail. We want to see where this goes. So let's get the motherboard out of this laptop. Well, I'm not seeing any problems on the back of the board either. Not seeing any dark marks on the interior of the laptop either. I mean, we had this layer here, but this copper tape is also not revealing any secrets other than bugs. Okay, well, in any case, let's keep tracing our power. So on the top side of the board, we got as far as these two DC-in MOSFETs, and then we went through some vias. So let's see where those vias are coming out. I'll flip the board over, and we are coming up here. So we're coming out here, and then we've gone onto this big power plane here, which also goes up to this section, and it also looks like it's going through another set of MOSFETs here. So this might be our VDC section, because also there's another fuse there as well. So I think this is where we want to be paying attention to, but I'm just going to see where this is going. We're going to another set of vias. Let's flip the board again, and those are coming out somewhere around the SSD. Oh, I hate it. I think it's right under the connector. I think it's directly under the M.2 connector, which means we're not going to learn anything from that. Okay, no idea. That might be to do with where... So that mystery input might be to do with the Type-C port up here. It might be where the Type-C port is getting power into the system. That would be my guess. However, that is a guess. Okay, fine. So I'm going to work from these extra two MOSFETs we found then. So let's see what's going on with these dudes. So once again, my black probe is on ground, and we should find this area is coming out of our DC MOSFETs, and it was about 300 kiloohms. And that's what we're seeing there, 300 kiloohms. So we're going through another set of MOSFETs here. Let's check the output here. And that's 100 kiloohms. That's still not shorted. I'm checking again on that fuse. Still nothing. Okay. I mean, unless this is where the Type-C power comes in. What about those 9 vias? What about those vias? Where is this coming or going? Right, so there's those 9 vias. Those are coming from an inside section of the board. So that may well be where Type-C power is coming in instead. And this section disappearing off down here, that might be where we go. Okay. Right, well, what else do we have then? If we look around the board, so we've got this far, but if we look around for other things that I can look for, we've got this massive fat power trace here. So what is that? Is that power or is that ground, I wonder? Well, let's follow that around. It's going down here, it's going along here. It's going to big power areas down here. So that must be power. What's this guy? What is your status? This is not going to be ground because it's got, again, big MOSFETs doing stuff here. If we check this side, these capacitors here, yeah, those capacitors are going to ground. So let's check this guy. There we go. There's our short circuit again. So what's going on here? We're on the other side of the battery charger. So this tallies with what I was saying about this being a VDC architecture. So this section here is where we're going from our battery volt. This is somewhere around here. We are converting our DC in voltage down to approximate battery voltage, and then the rest of the laptop is running at approximately battery voltage. So when I say narrow VDC, I mean a narrow voltage. So in a traditional laptop layout, the laptop's main power rail can be anything from battery voltage, which, like, if you have a 3-cell battery, that's going to be, I don't know, 11 or 12 volts, all the way up to 19.5 volts from the charger. That's quite a wide voltage band that you might be operating in. But with narrow VDC, you convert your 19 volts from the charger down to approximately battery voltage, probably whatever the battery charges at, which is going to be, say, I don't know, 12 point something or other, you know, maybe 13 volts tops. Whatever 4.2 times 3 is, basically. And so you convert down to that, and then you run your main power rail at that voltage. And also, what's with that capacitor there? That guy looks... Is that guy a bit sketchy, or is it just me? No, I think you're okay. I think that's just... There's little bits of glue on everything where there was sticky tape on this side of the laptop. Anyway, so I think what we have here is our VDC converter. We've got multiple inputs here. We've got a main rail here. There's a current sense resistor there. There's another current sense resistor there. There's a lot of stuff going on here. I wonder if we can figure out which one is our DC input and which one is our battery. If we flip the board again, here's our battery connector. And we've got our main positive pins coming in through here, going through a fuse, going through some inductors, and going into that cluster of vias. So let's memorize that layout. There's a group of 6, and then kind of like a serial-looking pattern there. There we go. There's our cluster of 6 and our serial-looking pattern. So this is the battery voltage coming in through here. So this is battery input. So by process of elimination, this guy over here, or these guys, are most likely our DC input. So we can check for this. So I'll put my black probe up there, and I'm going to come back down here, and I'm going to check that current sense resistor. There we go. We have continuity there. So this is from our DC in MOSFETs. So those were not shorted. So those guys are coming in through here. They're going through here. And then at some point around here, we're becoming shorted. So it could be this guy. What about all of this via stitching here? What's going on there? That's underneath that giant inductor, which doesn't help me a lot. Okay. Well, I'm getting a little bit lost here because I'm just trying to trace through the board without using schematics. I'm just trying to follow the money. Even if I do trace exactly where this thing is laying out, the answer remains the same, is that the main power rail is shorted. So I could figure out exactly what is going on there, but that will take time, and it's not actually going to discover the short circuit. At this point, I believe that we've identified enough that we can just go for voltage injection. So if I want to inject power into this motherboard, we've got to go through the checklist. Are we shorted? Yes, we are shorted. Our main power rail is shorted. We have verified that. Could we be shorted through silicon? So, could we be shorted through the CPU, for example? That's pretty unlikely because our short circuit is too low to be going through the CPU. Through the CPU, we'd kind of expect to see like a couple of ohms. But, we can probably check that. If we, let's see, can I see underneath that CPU heatsink? I can. We've got some inductors under this heatsink here. So what I'm going to do is I'm going to put my black probe on ground and I'm going to stab one of those inductors. Let's go for there and that. Oh. Well, that's the same. That's very low. That bodes extremely ill. That's not what I expected. Okay. Right, well, we need to confirm this because at this point now, I'm not sure if we're shorted through the CPU. I'm going to take the heatsink off. If we were going through the CPU, I'd expect to see a couple of ohms. This is fairly modern, though, this laptop. It's a 2020 laptop. So here's the little power stages that the heatsink was covering up. So once again, our main power rail here, you can see it's coming along here and feeding into those power stages. So let's check the input once again to confirm that we know where our short circuit is. There's our half ohm short. So if I go to the output from the power stage now, which is going to be the inductor, we're getting 0.3. See, the problem is we're trying to measure a very, very low value now. And this is where you start running up into the limitations of your multimeter. Because I'm asking myself the question, is the low resistance I'm seeing on the input the same as the low resistance I'm seeing on the output? And I'm trying to measure I'm trying to measure in the milliohm range now. And I got a cheap multimeter, and this is the time where that cheap multimeter might just trip you up. I think we're shorted through one of these power stages. Does any of them look like it's exploded? That looks kind of suspicious. Let's go in for a close-up there. That looks very suspicious, that one. If we compare to here, you can see, like, all of them have got a little bit of gross on them. You know, we've got a little bit of hairiness around here. That's kind of standard issue in a laptop. But look at the solder joints. You can see the solder joints are kind of frosty, the way that unleaded solder is. But if we go to this guy on the right, this solder looks like it's flowed recently. That's a little solder ball there that I just pulled out. This guy looks like he's our problem. I wonder if we take that off, if the laptop will run without it. But also, there's a very good chance that the laptop is also kill. Let's see. I'm going to take that off the board, and let's find out. So this guy's going to be problematic to remove because we've got this electrolytic capacitor right next to it. So let me see. I'm going to turn the board around, and I'm going to try and point my airflow in this direction. So we're hitting this, but we're going away from the CPU and away from this capacitor. But yeah, there's going to be some collateral damage here, I think. Or I could try removing the capacitor. I'll do that, actually. Editor's note, I made a complete hash of trying to get this capacitor off. I thought I was going to be able to just walk it off one side and then the other, but it did not want to come off the board for love nor money, and I ended up breaking it. However, at this part of the repair, it's not really important. This capacitor is not what is going to make the laptop turn on or not. So we can ignore this for now. Alright, well that capacitor just went kicking and screaming. I'm probably going to need to replace that, which is frustrating. However, it was going to get cooked anyway, so here goes nothing. Right, that came off with relative ease. A little bit of warmth in the board, but I think it's cold enough for us to take measurements again. Be wary of taking measurements while the board is hot. You can get deceiving results where things have flexed and things like that. So let's check if we're still shorted to ground. Black probe on a screw hole and positive pin. Yeah, we're up in the megohms there, so we're no longer shorted to ground. And if we go back to the output from this power stage, we'll see that familiar low resistance. So, like, that's mega low. I think this CPU is cactus. I can plug in some power and see if the board does anything, but I think this thing is dead. But let's see what happens for funsies. You never know. Maybe it'll do something. So I'm going to plug in a Type-C cable. We should plug in a DC cable, actually. I can't monitor a DC cable, but we can. But I know the Type-C cable might be a bit sketchy. So let's plug in a charger and see what it does. Bam. No light on the charger. I doubt it will want to do anything with one of the power stages off the board. So our main power rail is up. It's at 12.3 volts, so that's approximately battery voltage. And once again, you know, I've been talking about VDC. Let's look at the battery from this laptop. The battery is 11.1 volts nominal, which means it's a 3-cell battery. And you can actually see that if you look in the back, 1, 2, and 3. 9 times out of 10, if you count the cells, you'll probably find out how many cells are in the battery. There are some exceptions to this, like for example, if you see 4 cells, you might have 2 cells. It might be a 2x2 configuration. So that's not a sure thing. However, you can use that as just a barometer to see what you're looking at. However, 11.1 volts nominal, that's going to be a 3-cell battery, which is 3.7 times 3. And so we're seeing about 12 volts for our main power rail from the charger. So the charger is now putting power into the laptop. We don't have a fault condition, but also we've got no charge LED either. This also might be because we've got other stuff not connected to the laptop. So just for posterity, I'm going to just plug some other stuff in and I'll see if it wants to go, basically. I don't know what the rules are for having phases missing. We've got 3 stages that are all feeding into the CPU here. They're all common together. then there's an extra stage over here that is doing either System Agent or the integrated graphics or something like that. So I don't know if it'll run with one of those missing. The PWM controller for this, which is probably this guy here, is probably going to notice that one of the power stages is missing and be like, no, we will not turn on. But, you know, let's see. It's also quite likely that the CPU has seen high voltage, and so the CPU is quite probably dead anyway. And that would have happened originally when the power stage failed, so we don't really have a lot going for us at this point. I'm also just kind of freaked out at how low resistance the CPU is. I'm plugging in all of this I/O stuff just in case the laptop wants any of it to be present. It probably doesn't, but, you know, I can dream, Harold. I'll just rest the heatsink on top of the CPU, just in case it does want to go. If it does actually try to do something, I can just hold that in for cooling and see if we get a post. Right, we definitely don't need Wi-Fi. We've got the keyboard plugged in, so if we need that, then we can. I think we've got enough to just see if it'll do anything. So the PCH is where that warmth I'm feeling is coming from. And it's kind of only mildly warm because the PCH doesn't kick out that much heat compared to the CPU core. So right now it feels like our PCH is burning up and everything else is kill. So if I try to turn the laptop on, I can push the power button and the power light comes on, but after a moment it just goes out again. So most likely the laptop is trying to start, but it's detecting a fault and then turning off again. So now the question is if there's any mileage in going any further, and at this point I don't think there is, because our PCH is heating up and putting out a sizable amount of heat, and it shouldn't. So being real at this point, even though the laptop has given us some signs of life after clearing this short circuit, I can't see a world where that CPU still works properly. It might be cutting out because there is a power stage missing and it's going, no, there's a problem, we're not going to turn on. But also, because we had a shorted power stage, and it was directly shorted, this laptop has definitely seen high voltage into the CPU, if only for brief moments. So from my perspective, it's really not worth the hassle of tracking down another spare power stage to solder on there and find out, because the chances that the CPU is okay are extremely slim. So I'd end up ordering parts, I'd end up ordering specific parts only to find that the laptop is dead anyway. I'll just disconnect the battery and I'll just try it again just for good measure. Yeah, it's just turning on and putting out power on the USB ports. And the PCH is giving heat. So sadly we're all done here. Kind of a bummer to do another fail video and also it be another dead PCH. There was a comment recently where someone said, oh, seems to be a lot of dead PCHs lately. You know, it seems to be a growing problem. I think they've always been there. But the thing is that I have reached a skill level where I'm able to recognize a dead PCH with greater ease. Because, you know, I'm learning, it's not that the PCHs weren't previously dying, but previously when I would encounter one, I wouldn't know what the signs of that looked like, and I would just go, I don't know what's wrong with this motherboard. And typically that's not the kind of video that I would put out, because I couldn't say any useful information. I couldn't give any kind of resolution as to what I think had happened or why. Whereas now I've learned enough to be able to go, okay, clearly the CPU and or the PCH has died. So there's actually some mileage in showing this video, because I can show you how I got to that conclusion and how you can recognize the signs yourself when you're working on these things. I'm sure some people would then start saying, oh, well, you know, you could replace that power stage. You could replace that, that CPU with a BGA reflow workstation, etc. But for me, I'm definitely not at that stage. If the customer wants to spend the money for someone to find out, they're more than welcome. But for me, this is the point where I go, no thanks, Chief. I won't be charging for this repair because I don't charge for a no fix. I've done enough to get to the point where I don't believe that I can fix this laptop. So that's the point where I tap out. So I hope you guys found it kind of interesting to at least look at the board and see how we approached this problem. And past that, I'll see you guys next time, hopefully with a fix, because yeah, kind of feel like I need a win at the moment. Thank you all. Bye for now.